guys, how are you all? This is the third tutorial video on SAP 2000 for beginners, and in this video we'll learn how to do modeling of a building using the architectural drawing. Okay, so for this tutorial I have taken a sample file. Alright, okay, so these are the elevations of the building, and these are the plan. So it's the ground floor, we got a first floor, then we got a second floor, and we got a roof. Okay, so this is the section: ground floor, the first floor, and the second floor, right? Okay, so after having knowledge of the architectural drawing, first thing you need to do is that open your SAP and go to file, click on new model, and select grid only. Alright, and hit OK. Alright, so as you can see in this architectural drawing, the units used are feet and inches, right? So we select the unit here as feet. Okay, so keep is the unit of force, we don't need it now, so we need feet as the unit of distance. After that, double click here and hit spacing. Alright, okay, so first grid in the X direction. Alright, so this is the X direction and this is the Y direction, as you can see here. So first spacing in the X direction is 11 foot and 7 inches. So what you do is you put here 11 feet and you just do 11 plus 7 divided by 12. So it's 11 feet and 7 inches. So make sure it's spacing here, not the ordinates, right? Okay, so after that, next spacing is 11 feet and 11 inches. Okay, so we do 11 shift plus 11 divided by 12, hit enter. So we don't have any other grid, so we put a 0 and delete this grid line. Alright, and in the Y direction, as you can see, the first grid spacing is 12 feet and 5 inches. So we put it here, 12 shift plus 5 divided by 12, enter. Second grid spacing over here is 10 feet, so we put 10 feet, enter. And third grid spacing is 14 feet and 7 inches. So make sure you are using column to column center line as your grid spacing, right? Okay, so the distance from this column center line to this column center line is 10 feet. That is why I have taken 10 feet as the grid to grid center line or grid spacing. So the final is 14 feet and 7 inches. So you do 14 shift plus 7 divided by 12, that is 14 feet and 7 inches. So enter, and 10 is mandatory at last. Alright, so we did for X and Y direction, so X and Y direction. Alright, so now let's move to the Z direction. Okay, so so in Z direction, different designers have different approach. Okay, some designers prefer to fix their columns at the ground floor, however other designers prefer to fix their columns at this ground floor. Okay, ground level and the ground floor. Alright, so I prefer to fix my columns at the ground floor, so we'll begin from here. Okay, so we put a grid line for this plinth level, and for the first floor slab, second floor slab, and this roof. Alright, okay, so first spacing we got is 9 foot 4 inches, and rest are also 9 foot 4 inches. So we put 9 shift plus 4 divided by 12, enter. So we got this grid line now, so we need to put another grid line, this one. So you put it 9 shift plus 4 divided by 12, enter, and final 9 plus 4 divided by 12, enter. We delete it, and one final 0. I think I changed it. So 9 plus 4 divided by 12, enter. Okay, so this is it. Click OK. Okay, so if you just don't see your grid, don't panic. You need to hit XY plan So this is it, and in the grid we got our grid data in 3D view. Alright, okay, so let us see. Yeah, it's just good. Alright, it's just good. Okay, so after setting your grid, first thing you need to do is define the materials. Okay, so we go to define and go to materials. For designing a RCC section, you need to define concrete and you need to define the steel. Steel means rebar, right? So you click on add new material then and hit. If you belong to any of these regions, select your region. I belong to Nepal and I don't have Nepal here, so I choose my neighbor India. Alright, so material type is concrete and standard is Indian, and grade I'll take M20. So I got my material here. So if you want to modify the property of this selected or defined material, you can click on this material and click on modify so material properties, and you can see the properties here, right? So it's 24.996 weight per unit volume, that is 25 kN per meter cube. So modulus of velocity is 5000 root over FCK, and specified compressive strength, its FC dash is 20 MPa. Alright, so it's click OK. So now having defined the concrete, now we define the rebar. So click on add new material, and here you don't select steel, you select the rebar. Okay, so HYST I'll use FE500. Click OK. So let's change some of the properties here. So we rename is a FE, and let's select it as 78. It's 0.5 kN per meter cube. Modulus of velocity, it's okay, that is 2 × 10 to the power 8 kN per meter square. And okay, so Newton per mm. So minimum yield stress Fi is 500, minimum tensile stress is also 500, and expected yield stress is 1.1 times 500, that is 550, and expected tensile stress is also 550. Okay, so change your values like this and click on OK and click on OK. So after defining the materials, now you need to do is that you need to define the sections. That means that you need to define the section of the beam and a section of the column. Okay, so now hit on define and click on section properties, and beam and frame come under frame sections, therefore you click on frame sections and click on add new property, and here you just select concrete and click on rectangular. Okay, and name it as okay, so first let's change the unit to meter. Alright, so define section properties and frame sections, add new property, rectangular, add new property. Okay, alright, so here we do as beam. Okay, so depth of the beam, this is the first trial for the depth and width of the beam, and this size you don't put randomly, you do is the preliminary design of this building first. Okay, so you got your architectural drawing, and first thing after getting the architectural drawing, you should do is that you need to do the preliminary design of beam, column and slab. So if you don't know how to do the preliminary design of these structures, I have made other videos, you can watch them and learn how to do the preliminary design and do accordingly. And after you get the sizes, you need to put it here. Okay, so for this case, I'll take depth of the beam as 350, 0.35, and width as 230, 0.23. Okay, so material I'm taking M20, and concrete reinforcement, here it's beam. So longitudinal bars FE500, and confinement bars, that is ties, it's FE500 still. So beam. Okay, so longitudinal cover I'll be taking 25 mm, so that is 0.025 meter, so 0.025. click OK. Alright, okay, so and after doing this, just click OK. Alright, so again I need to define the column, so you do is add new property, rectangular, so column, column, column. Alright. Okay, so depth, I'll be taking 0.35. So I'm repeating this thing, that this size comes from the preliminary design. So first you do is preliminary design, and after that only you can put this size. Okay, so width 0.35, and the material I'll be taking M20, and concrete reinforcement. So longitudinal bars FE500, this is fine, and confinement bars also FE500. So design type is column. So reinforcement configuration is rectangular B column, and clear cover for confinement bars is 40 mm is fine. Number of longitudinal bars along 3 direction face, that is along this direction 1, 2 and 3 bars, and along 2 direction face, that is 1, 2 and 3 bars. Okay, so 1, 2 and 3 bars, sorry. Okay, so alright, so longitudinal bar size, first trial I'll be taking 16D. Okay, so confinement bars, number of bars, diameter of bars I'll be taking 80, and longitudinal spacing I'll be taking 100 mm, that is as per the calculated detailing. Number of confinement bars in 3 direction face is 3, and in 2 direction face is also 3. Okay, so check design, reinforcement to be designed must be checked, and click OK, and click OK, and hit OK again. So you got your beam and column. So now you need a slab. Alright, so again go to define and go to section properties and hit on area sections, because a slab is an area section. Alright, so after that this must be cell, and click on add new section and type. Okay, so let's name it slab. I'll be taking 130 mm slab. Alright, so slab, it must be thin. Thick slab you usually use for the dams and other heavy structures. Alright, so thickness of the slab is 130 mm, that is 0.13 meters, so 130 mm. Alright, so material is M20, material angle must be 0, and click on OK, and click on OK. So you got your beam, you got your slab, and you got your column. Okay, so after defining the section sizes, just go to XZ plane. Alright, okay, so now we are in the XZ plane. Okay, so that means that this is your X, and this is your Z. So you're looking, you're drawing like this, you know. So in SAP you need to visualize your drawing. Alright, so this is your X and this is your Z. So you're looking, you're drawing vertically. Okay, so first we'll draw this and this column. Alright, so for that you can click on draw and draw frame cable tendon, or just you can click over here and select this as column, and we draw like this. Okay, there you go, and right click this and this, right here. Okay, alright, so we have now drawn these 1, 2 and 3 columns. Now either you can draw these 3 columns, or what you can do is that you just can copy these 3 columns into this grid. Okay, alright, so for copying the columns, you just press escape, and after that select these 3 columns and go to edit and click on replicate. Alright, okay, so we are replicating in the Y direction, right? So in the Y, this is the Y direction, so we are replicating or copying these 3 columns in the Y direction at a distance of 12 feet and 5 inches. So we keep dy as, alright, so first make the unit as keep feet. Alright, okay, so alright, select these 3 columns and go to edit and click on replicate, or you can press Ctrl plus R. Alright, so dy, it's 12 feet and 5 inches. Okay, so hit enter. Number of copies just keep 1 and click OK. So now you see you got your 3 columns. Okay, alright, so this is the XZ plane at y is equal to 0. So y is equal to 0 is at this place, right? So you are here. Okay, so you move one step further into this, right? So you are here now, and you have to move one step further into this grid. Alright, so we are at this point, no, so we have to move here. Alright, so for that click on this up in the list icon. So now we are in this grid. So up in the list doesn't mean up in the Z level only, right? Up in the elevation only. So it means its meaning varies according to the plane you have selected. Okay, so now we are here. We again select these three columns and click Control plus R, and dy, now it's only 10 feet, right? So we have to copy it by 10 feet. Okay, click OK. So we got our columns, right? Again go up and select these three columns, that is these three columns, and click Control R. So we have to copy it by 14 feet and 7 inches. 7 divided by 12. As you can see in the drawing, it's 14 feet and 7 inches. Okay, so click OK. Now we got our columns of the ground floor. Alright, okay, so having drawn these columns, now we have to draw the beams. And for drawing the beams, click on XY plane again. At z is equal to 0 means we are at this level, and we don't have any beam at this level except for the tie beam, so we are not drawing the tie beam in this model. So we don't have beam at this level, so we have got beam at this first floor level. Okay, so we go one step up. Now we are here, and now what we do is that we draw the beam. So click on this draw frame cable and we select it beam here, and now we draw the beams. Alright, nice and easy. Let's go all the way. Now click on right mouse button and again start drawing. Right mouse button. Alright, so there you go. So as you can see, we got our column and we got our beams. Now the next thing we need to draw is slab, right? So we got a slab here, 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 but this is the staircase, so we don't have any slab here, so we don't draw any slab at this panel. Okay, so click on this draw rectangular area and we got slab 130, and click on this point and drag it all the way up here, right? Click on this point and drag it all the way up here. Alternatively, you can just draw quick area and click like this, and you will see we got our slab. Okay, so now let's just see the slab in the extrude view, and click on this set display options and click on general options, extrude it, fill objects, and click OK. Again go to click on this window and click on the here and click OK. Yeah, you see now you got your slab, beam, and column for the ground floor only. Okay, so as you can see now we got our slab, beam, and column. So what we can do is that as our height is same for all rest of the floors, we can just copy this floor into other floors, right? So for that select all everything you have drawn and hit Control plus R, and in dy it's 0 and dz it's 9 feet and 4 inches. So you got 9 plus 4 divided by 12, right? And number of copies we make 2, so one for the first floor and another for the second floor, so it's 2 copies. Alright, so click on OK. Alright, so as you can see, so we got our model here, right? Okay, alright, so this is our model of the building. Yes, this is great. Alright, okay, so right, so this is the ground floor, first floor, and this is the second floor. As you can see, in the second floor we got a little projection here. Okay, so I didn't forget this projection. So this is how I model the building. So what I do is that I just simply start from the simple things, so simple grid, and I keep on adding any complex things that come on my way. Okay, so we got our we got in the second floor plan and in the and also on the roof. Alright, so let us first see what is the distance. It's 4 feet and 6 inches in the y direction. Okay, so double click here. Okay, so you got your origin here and it's below the origin, so it's negative. Alright, so you add it, and it must be ordinate, and minus 4 feet and 6 inches, that is 4.5 feet. and click on OK. It's minus. Okay, so click OK. Oops, what is this? Oh, sorry. I think the unit is just fine. Alright, so how it this we should delete. We don't have this. We add it. There must be some error. Minus 4.5 and hit enter. Okay, so hit enter. Alright, so I think I forgot to hit enter. So click OK. Now you can see you got your here. So our 3D is missing. So hit this window and click on 3D. Alright. Okay, so this is the first floor, and we got in the second floor. We again draw a rectangular area. We got a slab here. Again, we go one step up on the roof. 28 0. So this is the roof. Alright. I'm sorry, I think I drew it in the first floor. Okay, so we got here, and one step down we got here the small projection, and we don't have any projection here. Alright, okay, so these two projections, for this projection and this projection. Alright, okay, I think we're just fine. So now, so we have drawn the building. Anything left? I don't think anything is left here to make. Okay, so now we have to draw the staircase. Alright, so staircase. Okay, so for that, let's see the section, and this is our section, and let's take the height. So it must be 3 feet and 6 inches. So it must be half of 5 feet and 10 inches. Okay, so having to model the building. Alright, so now we need the staircase. Alright, so as you can see in the drawing, we got like open well staircase. Alright, so we need a grid for this line and this line in the y direction, and this line in the x direction, and now this line, and this line in the z direction. Alright, so it's a complex thing for drawing a staircase, especially the open well staircase. Okay, so but however, you just need to focus your mind here. Alright, so in the x direction, what you need, so you need this grid line for this landing, and this grid line for this landing, and this landing, right? Okay, so this grid line is at an spacing or at an ordinate of, so let's just check it here. So from origin, this grid line goes like, okay, so it's 15 feet and 7 inches. Alright, so this grid line is at a distance of 15 feet and 7 inches from the origin in the x direction. Okay, so we do it. Let's add the grid. Okay, so alright, so it's the ordinates and the unit is feet. Alright, so we add 15 6 plus 7 divided by 12 and hit enter. Alright, okay, so again we need another grid for, alright, so from here to here for this landing. Alright, so it's 4 feet and 5 inches. Okay, so 4 feet and 5 inches. So we add 15.5833 plus 4 plus, it's how many inches? 5 inches. Alright, so 5 divided by 12 and hit enter. Okay, so we got 2 grids. Let's click OK and let's see. Alright, so we got here 2 grids for this and this. Right, same we need this and this. Alright, in the y direction. So let's take the distance. Let's see. Alright, from the origin, so this is our origin, right? Okay. Alright, so from here, so we need for this line it's how much? 15 feet and 11 inches. So we add, let's add a 15 feet and 11 inches. Enter. Again we add here to here, that's 3 feet. Alright, so 15.9167, 15.9167 plus 3. Enter and click OK. Alright, so as you can see we got, oh, our 3D view is started, don't worry. Alright, so we got our X and Y, great, and now we need it in the Z direction. Alright, so in the Z direction, double click again, right? So in the Z direction, so you need a line at 3.6 feet for this landing and 2.4 feet for another landing, and at 3.6 feet for I think we got this grid line. So you need a line at for 3 feet 6 inches for this landing and 2 feet 4 inches for this landing, plus 2 feet 4 inches. Okay, so click on add, it's 3.5, hit enter, that is 3 feet 6 inches. Oh, we don't see Z6, let's name it Z6, enter and click again on add, Z7, it's 3.5 plus 2 feet 4 inches, right? So 2 Z plus 4 divided by 12 and enter it, click OK. Okay, so after defining the grids for the staircase, we need to model the staircase and fit it into our building. Alright, so before starting the modeling of the staircase, we need to define the slab for it. Alright, so change your unit to mm here and go to define, go to section properties, area sections, and click on add new section. Let's name it slab 125. And thickness is 125 while it's the membrane, and in bending also thickness is 125 and M20. Click OK and click OK. Alright, after that go to the 0 level, Z is equal to 0 level. Okay, so as you can see, so we got a landing slab as 3 feet 6 inches from here, right? So that gives us from the center line as 4 feet 5 inches. Alright, it's okay. Alright, so this is our landing, right? Okay, so this is our landing. We got a slope, then landing, then slope, then landing, then slope, right? So we don't have any slab at the ground floor, so we begin with this slope, poly area, and section here you need to select slab 125, not slab 130. Alright, okay, so we click here, one step go up here and again here and hit enter. So then we go to this and we again click on here, go to one step up here and here, hit enter. Again we need a landing slab, then again here, not there, so we have to begin from here, go in the anti-clockwise direction, here and here, hit enter, that's correct, and draw the final area, right? Okay, so we got our slab here, as you can see in the 3D view as well. Now we need to copy this slab to our other floors, so change the unit to feet, and selecting for copying this slab to other floors, you need to select it first, and selecting these inclined slab is very tough. You cannot do it in the XY plane, you have to do it in the 3D view, and it becomes very tough if your model is complex. Alright, so there is yet another way for selecting the slab. You have to go to select, click on select and click on properties and click on area sections and click on slab 125 and select. As you can see, we got our slab selected. After that, hit Ctrl plus R. Now digit it's 9 feet and 4 inches. So number of copies we need 2 and click OK. Alright, so as you can see here in our 3D view, we got our full drawing here. Alright, open our staircase as well as our model. Alright, okay, so this is it. Alright, so alternatively what you can do is that you can design a jet beam for this slab, but I won't be making jet beam, because jet beam might cause short column effect in this column and create this failure even if the reinforcement is correct. Alright, okay, so so this is the first floor plan. As I can see here, there is a balcony. Alright, so I don't think we have added balcony over here. So what we do is that we add a balcony in our first floor. Alright, okay, so let's add a balcony. So slab 130, right? So we add a balcony here. Alright, so is it okay now? Alright, so there is a balcony, and in the second floor, alright, so okay, there is let's just do it XY. Alright, okay, so let us see the architectural drawing over here. Alright, okay, in the second floor you can see there is open terrace. That means that you got slab over here, you got slab over here, but there is no slab here. So as you can see in the roof, it says open terrace below. That means that this is a slab and there is no slab in this region. So we need to do we need to delete the slab of this floor. Alright, okay, so let's do it. Let's go there and let's just delete this slab as well as this panel. So we don't need this beam, these two beams, and we don't need the column as well. So let's go to XG plane, let's go up until we find this column and delete it. Alright, okay, again go to XY plane. As you can see in the roof, there is no staircase opening. In the architectural drawing you can see here, right, there is no opening for the staircase, so we have to close it. Okay, let's delete this slab and draw another slab that goes from here to here. Okay, let's do it. Alright, let's rotate it and let's see. Okay, yeah, now it's good. Okay, so this is the final version of our SAP model. Okay, I think now we are fine here. Alright, so this is how you model your building. Just begin from a simple thing and keep on adding whatever you want, any sections or staircase or whatever comes in your way. Keep on adding them. So don't begin from your complex grid. If you do, you might get confused and make blunder. Alright, this is it. Hope this video was helpful, and if it was, hit like and subscribe for more awesome videos. Thank you.